Welcome guys, today I'm going to be proving that this expression on board is divisible by 91 for all positive integers n. And we're going to do this using the amazing method of induction. So for induction, first we need a base case, so let's get that out of the way. For positive integers, that means it's going to be n0 and above as an integer. Okay, so our base case is going to be 9 to the power of 2 plus 10 to the power of 2 times 0 plus 1, so just 1, and that is equal to 91, which is in fact equal to 91 times some integer. It's divisible by 91. All right, let's continue with our induction hypothesis. We need to now assume that our statement above is true and prove that the statement holds true for a case of n plus 1. Okay, we're going to assume that 9 to the power of n plus 2 plus 10 to the power of 2n plus 1 is equal to 91 times some integer m. That means that it's divisible by 91. Okay? From this, we can also easily derive that 9 to the power of n plus 2 is equal to 91m minus 10 to the power of 2n plus 1. I just moved 10 to the power of 2n plus 1 to the other side. And this is a very useful trick that I actually used in my last video. So with this, we have to show that this case is true for n plus 1. Okay? We have to show that 9 to the power of n plus 1 plus 2, so n plus 3, plus 10 to the power of 2 times n plus 1 plus 1, again it's going to be 2n plus 3, is equal to, let's say, 91l. It's a different integer this time, but also divisible by 91. Same concept. Okay, and we're going to do this by using our original statement, and we're going to be substituting in 9 to the power of n plus 2. Okay, so we have to, seems like, multiply 9 to the power of n plus 2 times 9. Then we're going to add 2 times plus 2n. Okay, so we have 9 to the power of n plus 2 times 9. So it's going to be 91m minus 10 to the power of 2n plus 1 times 9. And then plus the rest. So what I did here is I basically want to show this. I split apart 9 to the power of n plus 3 into 9 to the power of n plus 2 and an additional 9 to get that extra 1 in the power. And since we assume that 9 to the n plus 2 is equal to this right here, I can substitute this in here. And we're still trying to show that this whole equation is true. Okay, so then we get that 819m minus 9 times 10 to the 2n plus 1 plus 10 to the 2n plus 3 is equal to 91l. Okay, now it seems that we're pretty stuck. We have minus 9 times some power which base is an exponent of 10. So what can we do here? It's actually not that bad. Remember that 9 is just 10 minus 1. So we can distribute 10 minus 1 over all of this. Okay? Remember that 9 is equal to 10 minus 1. So if we distribute this over here, we get our 819m minus 10 times 10 to the 2n plus 1. So 10 to the 2n plus 2. Then plus, it seems, minus 1 times minus 10 to the 2n plus 1. It's going to be plus 10 to the 2n plus 1. And plus the rest. Okay, but now it seems like we're stuck, right? Yeah, it really does. We have 3/10. We have to show that it's divisible by 91. We have this part's divisible by 91. What can we possibly do? However, there's a very nice factoring trick I can show you. Consider 10 to the 2n plus 1, and all of these additional ones. So yeah, let's look at 10 to the 2n plus 2 in regard to 10 to the 2n plus 1. It's equal to 10 to the 2n plus 1 times 10, obviously. Right, we multiply by 10, we have our power added there. Now how about 10 to the 2n plus 3? It's equal to 10 to the 2n plus 1 times 100. We're adding 2 powers now. We multiply by 10 to the power of 2, which is 100. And what do we notice about our upper expression here of the 3 10 to some powers? Notice that 10 to the 2n plus 1 is positive, so we multiply this exponent times 1 times itself. Notice that this exponent 2n plus 2 is negative, so we multiply by a negative 10. And that this exponent 2n plus 3 is again positive, we multiply 2n plus 1 times 100. Okay, so we actually have that 10 to the 2n plus, let's say, 3 minus 10 to the 2n plus 2 plus 10 to the 2n plus 1 is equal to 10 to the 2n plus 1 first times 100, then times minus 10, 10 times itself, 1. And what is 100 minus 10 plus 1? It's equal to 91, which is beautiful. We have factored out now this, and we see that 819m minus 91 times 10 to the 2n plus 1, with some very clever factoring, is equal to 91L. And from here, it perfectly makes sense. 819m is equal to 91 times some k minus 91 times some other k is obviously going to equal another 91 times some k. A multiple of 91 minus a multiple of 91 is equal to a multiple of 91. And therefore, we have shown that this expression for case n plus 1 is in fact divisible by 91. We have proved the induction step, so we have proved the initial statement. This is going to be divisible for all n in the positive integers. And that is it. Thanks for watching.